Hi everyone, in this video we're going to be learning about the division of fractions, and in Korean we call this 분수의 나눗셈. For this lesson we have four main objectives. The first objective is 분수와 소수의 정의에 대해 알아봅시다. So let's learn the definitions of fractions and decimals. Our second objective is 분수의 성질을 알아봅시다, which means we're going to be taking a look at the properties of fractions. Our third objective is 공약수, 약분, 기약분수, 통분 등의 뜻을 알아봅시다, which means we're going to be learning about common factors, reduction, irreducible fractions, and reduction to a common denominator. And our fourth objective for this lesson is 분수의 나눗셈을 알아봅시다, which simply means that we're going to learn how to divide fractions. First, let's take a look at the definition of 분수. 분수는 두 수를 위아래로 쓰고 위의 수를 아래의 수로 나누는 수입니다. 위의 수를 분자, 아래에 있는 수를 분모라고 합니다. So, 분수 in English we now know is called a fraction. The 분자 and 분모 of the fraction are the numerator and the denominator. So when I personally tried to memorize 분모 and 분자 when I was going to a Korean school, I kept mixing the two up, so I would put a post-it note on my mirror with the translations on them, but that didn't really help. So an easy way to remember what 분자 and 분모 means is to think about what 모 and 자 means. So 어미모 is the Chinese character for mother, and 아들자 is the Chinese character for son. So if you look at the fraction and think about the denominator as the mom piggybacking the numerator, the 분자, it's kind of easier to remember the definitions for these two terms. 분수값을 계산하여 소수점을 갖는 수로 표현하면 분수가 소수가 됩니다. So decimal numbers are numbers that are expressed with the decimal point instead of in fraction form. So as an example, the fraction 3 over 100 in decimal form is 0.03. Let's take a look at a basic example of how to divide fractions. So the question asks us, 분수 2분의 13을 소수로 나타내지요. Compute the fraction of 13 over 2 as a decimal number. Now I just want to point out that in English we would read this fraction as 13 over 2 or 13 halves, but in Korean, instead of stating the numerator over the denominator, you have to call out the denominator first. So in Korean we would read this as 2분의 13. So you would say the denominator 분의 numerator. Okay, so for this question, you just divide 13 by 2 as it's shown in the solution here, and the answer comes out to 6.5. So 6.5 is the decimal number form of the fraction 13 over 2. 분수의 분자와 분모의 같은 수를 곱해도 분수값은 같습니다. This means that a fraction's value is unchanged if we multiply the numerator and denominator by the same value. So we can see in this example that 3 over 9 has the same value as 3 over 9 times 3 over 3, 3 over 9 times 4 over 4, and 3 over 9 times 3.8 over 3.8. The reason that all of these fractions are the same is that any number divided by itself is equal to 1. So basically 3 over 3 equals 1, 4 over 4 equals 1, and 3.8 over 3.8 equals 1. So what we're doing here is we're multiplying 3 over 9 by 1, so the value of the fraction does not change. This next point is pretty easy. 분수의 나눗셈을 이용하여 구해지기도 합니다. This just means that a fraction is another way of expressing a division problem, and you can find a fraction using division. So this example says 3 divided by 9. In place of the division sign, we can put the fraction line. So 3 divided by 9 is equal to 3 over 9. Let's take a look at the definition of 약수. 어떤 수를 곱셈의 형식으로 나타낼 때 각 수를 약수라고 합니다. So when a number is expressed as a product of smaller numbers, we call the smaller numbers that comprise the larger number the factors or divisors of that number. And in Korean, this is 약수. So 아래 예에서 3의 약수는 1과 3이고 9의 약수는 1과 3입니다. So we can see here that the factors of 3 are 1 and 3, and the factors of 9 are also 1 and 3.
A 공약수 is a common factor or divisor. 공통되는 약수를 공약수라고 합니다. So factors that numbers share in common are called 공약수. 아래에서 30과 60의 공약수는 5, 3, 2입니다. So as you can see below, the common factors of 30 and 60 are 5, 3, and 2.
Now let's take a look at the definition of 약분. 약분은 분모와 분자의 공약수를 나누어 없애주는 것입니다. So 약분 in English is reduction, and this is the process of eliminating the common factors of the numerator and denominator. So in this example, we can see that the factors of 3 are 1 and 3, and the factors of 9 are 1 times 3 times 3. The numerator and denominator both have 3 as their factors, so we can cross those out and reduce the fraction 3 over 9 to its simplest form, 1 over 3. Let's take a look at a couple of examples. The instructions say 다음 분수를 약분하시오. Reduce the following fractions. So our first fraction is 12 over 36 and our second fraction is 15 over 12. Now the first step that we have to take is to find all of the factors of the numerator and denominator. So you can do this using the method on the right, or you can just list out all of the factors. But let's take a look. So the factors of 12 are 1, 2, 2, and 3, and the factors of 36 are 1, 2, 2, and 3, and 3. So we see that the numerator has a 2, 2, 3, and the denominator also has a 2, 2, 3, so we can cross those values out. And this leaves us with a final answer of 1 over 3 as the simplest form of the fraction 12 over 36. Let's take a look at another example. So 15 over 12. The factors of 15 are 1, 3, and 5, and the factors of 12 are 1 times 2 times 2 times 3. Now the only common factor between the numerator and denominator here this time is 3, so we can cross that out. But other than that, we just have to leave everything as it is. So our final answer is 5 over 4. 5 over 4 is the simplest form of the fraction 15 over 12. Let's take a look at the definition of 기하분수. 주어진 분수의 분모와 분자를 공약수로 나누어 약분을 하고 더 이상 약분이 안 되는 분수를 기하분수라고 합니다. So in English, a 기하분수 is an irreducible fraction or a fraction in its simplest form. And what this is a fraction where the common factors of the numerator and denominator have been reduced to the point that there are no more common factors between the numerator and the denominator, so the fraction is in its simplest or irreducible form. These are some examples that we saw earlier, but basically the fractions at the end are all the 기하분수 forms of the 분수 3 over 9, 12 over 36, and 15 over 12. You can see that we've crossed out all of the common factors between the numerator and denominator for each fraction so that there are no more common factors left to divide, and all we have are the simplest form of each fraction at the end.